Hi everybody, I'm Annie and Chris and I are presenting today on wayfinding for blind and low vision users. We'll be critiquing 3 existing applications for navigating unfamiliar spaces before presenting our own design. The first, Touchover, adds auditory and tactile feedback to existing visual maps, so the device vibrates and reads a street name as long as the user is following it with their finger. The first image here shows a smartphone map with several streets highlighted in different colors, and the second image is a recreation of that map drawn by a participant in this study. The streets are similarly color-coded, and it's a pretty close match to the original in terms of where the streets cross and intersect, although there are a few errors. Overall, users drew more accurate maps with the touchover feature than without it, but it only works for fairly small areas outdoors, and it quickly loses function when it's too zoomed out. It's also highly cognitively demanding for the user. The next app uses a camera and 2 algorithms to identify doors and interpret nearby signage. So basically, the authors looked at how sighted people navigate new environments. They find the elevator or walk down a hallway reading the room numbers, and looked for ways to provide that same information to blind users. The image on the left shows 6 different photos of doors that have been identified by this algorithm and are outlined in red. They include elevators and different visual styles of doors, and the photos are taken from different angles or are partial views, which is an important feature because a blind user isn't going to center the image perfectly every time. The door recognition algorithm is really successful overall, but the text recognition algorithm can be thrown off more easily, especially if there's extra visual information in the field. For example, it often tries to read icons as text as well. This is a pretty significant limitation because a lot of blind users already know how to find doors using white canes or guide dogs, so the interpretation of signage would be the most useful aspect of this app. The third app uses computer vision as well as an iPhone's gyroscope and accelerometer to read QR codes and give the user activity-based instructions, such as take 7 steps to the elevator and turn right. Beeping lets the user know how close they are to the next step, reducing cognitive load. The image shows a young user with a white cane in a hallway with the iPhone worn around their neck so the camera captures whatever they face. The code is just posted on the wall next to existing signage for a room, so this is a pretty easy system to add to the existing wayfinding tools for sighted users. It was highly successful for the small user pool in this study, and the QR codes were captured accurately in a lot of different circumstances. There is a potentially steep learning curve for non-cell phone users, and there are assumptions that come along with the activity-based navigation. I don't think it would work for users with some mobility impairments. But overall, these users reported a high level of satisfaction and interest in this application, and it was our main inspiration for the design component, which Chris is going to walk through now.
For the design portion of our project, we designed a computer vision-based phone application for navigating the University of Michigan Museum of Art and other museums. The main features of our application are GPS-based audio directions to safely guide users through the museum, a wearable camera, which tells the user what is in front of them, identifying doorways, stairs, art, and more, and lists of items in each room, as well as lists of exhibits, which help the user learn about the art and navigate through the museum. Our app features large buttons with high contrast text to make it more usable for low vision users. For wayfinding, users swipe in a direction on the phone screen and the app tells them physical directions to whatever is in that direction that they have swiped. The phone's GPS keeps track of the user's location within the museum. Users can also get directions to certain exhibits or art pieces through the lists of exhibits and art in the app. There is a button on the main page as well if a user would like to return to the entrance or wants assistance from a docent. The app has lists of exhibits with descriptions and directions to reach them so that the user can go on self-guided tours. The app can tell the user about an art piece they are facing using the camera or through the list of items in the current room. The app can take the user on a tour designed by the museum. Throughout the app, there are pause and play buttons to pause and continue audio, whether it's directions or art descriptions. Lists of exhibits takes us to a list of what's available throughout the museum with audio descriptions and audio directions from the Take Me There button. What's in this room tells the user what's in the room they're currently in and can take them to that piece of art. I Would Like Help allows the user to return to the entrance or call a docent. And What Am I Looking At activates the worn camera and describes and gives directions to whatever the user is facing.